All right, guys, here we go. Third and final video for the section 2.1. We're talking now about subsets, and the concept of subset is really simple. Let me give you a quick picture of what a subset is visually. Here's a set. Here's a bigger set. This guy here is the subset, the one that's inside of the other one. Okay? And now, sometimes you have also sets that are equal. Like the same set is actually its own subset because it's sort of vacuously true, right? It's automatically inside of itself. Let's look at the technical definition. So what is a subset? There's two qualifications. The first one is that it's a set. That's super obvious, okay? So a set A is a subset of another set B. First of all, A is a set. So of course, it's going to be a set to be a subset, right? It's even in the word. And two, every element of A is also an element of B. So if you're inside of A, you must also be inside of B. That's what it means to be for A to be a subset of B. Let's look at a simple example of a subset that we already know. We know that the natural numbers is a subset of the integers. What are you talking about? So let's look at notation too at the same time. So the way that we write this is we say A is a subset of B, like this. We write A, and that's the subset symbol there, is a subset of B. A is a subset of B. So we can say natural numbers is a subset of the integers. Why is that? Because think about what's in the natural numbers. It's things like 1, 2, 3, 4, etc., right? And what about the set of integers? What's that? Well, it's also got everything, 1, 2, 3, 4, and everything, etc. But also it's got other stuff, right? So it's got more things, but it has everything that's also it's got everything that's inside of the natural numbers, so that makes natural numbers a subset of it. Natural numbers is a subset of the integers. Now, I know it sounds kind of complicated the way I'm explaining it, but really it's super simple idea. A subset is just it's like a component of the bigger set. That's all. Now you notice in our symbol here, if you zoom in here, it's got this line underneath. Why is that line there, you think? What do you think? Any guesses? The line is there to say that equality is possible. They might be equal. So you can say something like this. You can say the natural numbers is also a subset of itself. In fact, that's true for any old set, any set. No matter what the set is, it's a subset of itself. Because they're equal, right? And you know, the analogy like this, it's similar to the way that we look at regular numbers. Like you can say something like 5 is less than or equal to 5, right? You can't say 5 is less than 5. That's not true. But you can say 5 is less than or equal to 5, right? That is true because, you know, they're equal. Okay, I made a note myself to draw the Venn diagram. I already did that. And also to remind me to introduce the empty set. So it's a reminder to myself to introduce to you guys the empty set. So what's the empty set? The empty set is just like what it sounds like. It's a set that has nothing inside. Nothing inside. So it's an empty set with no elements. And this is one standard way that we write it. Just write the brackets with nothing inside of it to indicate that it's empty. Another alternative notation, if you don't like that notation, you can just draw it as it looks like a circle with a line through it. And so if you happen to write your circles like this, then that's going to be confusing. So I recommend to not do that for this class. I know that's kind of hard to just like tell you to change the way that you write your zeros. But for this class, to not confuse ourselves, we want to reserve this symbol for the empty set, okay? So it's the same thing as writing this symbol here. The set with nothing in it. Okay. Now, to answer some questions, what are the subsets of the set with just 1 in it? And then question 9, what about 1, 2? What about 1, 2, 3? And then here's a big question. In general, how many subsets of n elements are there? Okay, big questions. And then after that, what's a proper subset? Okay, these are all big questions. You know what? I was planning to make 3 videos, but I think it's going to be... This one is going to go too long. It's going to have too much information if I make only 3. So I'm gonna finish this page with this video, and then we'll do the next page in the following video. Okay, so this page, let's talk about... Okay, we talked about what subsets are. We drew the Venn diagram. We also talked about the empty set. Let's talk about the subsets. And I'll give you this first one for free. The subsets of the set with just 1 in it are, there's 2 of them. You get the empty set. Why? Why is that a subset? Well, because look at our definition of subset. Is it a set? Yes, it's a set. And is everything that's in this set inside of that set with 1 in it? Well, yeah, automatically, because there's nothing in the empty set. So anything that's in there is kind of automatically, vacuously inside of the bigger one. So that brings up another fact. The empty set is actually always a subset of any set. It's always a subset. Okay, so what are the subsets? The empty set, first of all, and then the set itself. Okay, now try 9, 10 on your own. In fact, try 9, 10, 11, 12 on your own. Pause the video and just try the questions out. Once you've given it an honest attempt, then you can continue watching. Okay, so what are the subsets now of 1, 2? Well, first of all, the empty set again, right? And then you have sets that have just 1 thing in them. The set with just 1. The set with just 2. And then you also have the set itself. 1 and 2. Yeah, okay. Okay, what about the set 1, 2, 3? What are the subsets? Well, first of all, you've got the empty set. You've got all the sets that have just 1 thing in them. And then you have all the sets that have 2 things in them, so 1 and 2. And be very careful with the notation here, guys. Why am I writing commas between the sets? That's to indicate that each of these is a different set. And then each time I start a set, I open up a fancy bracket and then close it, yeah? Okay, so let's continue. So I have those. I have 1 and 3. That set. I also have the set with 2 and 3. And then lastly, I have the set with all 3 elements, 1, 2, and 3. Okay. Now question 11 says, how many subsets of a given set of elements are there in general? Again, try it out before you look at the answer. But let's kind of let's see if we can find any patterns, first of all. So how many subsets were there when there was just 1 element in the original set? Oh, there's 1, 2, right? What about when there are 2 things? 1, 2. There's 1, 2, 3, 4. There's 4 subsets. And when there were 3 things, there was 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets. So let's make a little table of our observations here. Let's say elements, the number of elements in one column, and then the number of subsets. Oh, in case you're not familiar, this symbol over here stands for number. I just shorthand for number because I don't have space. So number of elements versus number of subsets. Okay, so if it's 1 element, we saw that there's 2 subsets. If there's 2, we saw that there are 4. If there are 3, we saw that there were 8, right? And if there were 4, what do you think it would be? If you said 16, you are correct. And what's the pattern here? Well, 2 is actually just... Let's change colors here. Check this out. And try to spot the pattern before I tell you, actually. So pause it if you can. What is 2? 2 is equal to 2 to the first power. Oh, look. That's that 1 right there. What's 4? 4 is 2 to the second power. Oh, look, that's 2 right there. What's 8? 8 is 2 to the third power. By the way, what's power? In case you're not familiar, power just means multiply that many times. So 2 to the 1 is 2. 2 to the 2 is 2 times 2. 2 to the third is 2 times 2 times 2. That's what the notation means. Okay, what about 16? 16 is 2 to the fourth. It's 2 times 2 times 2 times 2. So we see that pattern continuing, right? What if I went down to n? What do you think it would be? It's going to be 2 to the n. And that's the answer to the question. If I have n elements, how many subsets are there? There's going to be 2 to the n. And be careful here. Make sure that the 2 is always the one on the bottom. A lot of people write n squared, but that means something different entirely. That means multiply the number by itself twice, but I want to multiply 2 that many times, right? However many elements I have, multiply by 2 that many times. All right, last question of this page. What do you think a proper subset might be? Again, give it your honest guess before you look at the answer. And then what's the difference between that and a regular old subset? So a proper subset just means that you're not the original set itself. Okay, so that's all it means. So what does it mean? It means a subset that isn't the original set itself. What does that mean? It just means that A is not a proper subset of itself. Wrong. That's wrong. And here's the proper subset symbol. I just wrote it just now. Contrasted with the symbol we saw earlier, which had the line under it, right? Line under it means it could be equal. So what is this like? It's really, remember I was talking about less than or equal symbol? It's even more apparent. That's what it is. Let's talk about this analogy here real quick. Okay, so let's talk about the number world, regular old numbers, which we're hopefully kind of familiar with. I'm gonna change my pen thickness here. So we've got regular old numbers, right? And today we're learning about sets. Okay, so with regular old numbers, you have things like, you could say something like 5 is less than or equal to 5. That's true. We're happy about that. But you cannot say 5 is less than 5, right? No, that's not true. Well, what's the analogous thing for sets? Well, you could say that a set, let's say just some random set A, is a subset of itself. Yeah, that's true. But you cannot say A is a subset of itself. That's not true. Okay, you know what's maybe might be throwing you guys off here is the fact that I'm using just it's like an amorphous set here. Let's make it a little more concrete. Let's pick an actual set. So let's say the set 1, 2, 3. Well, that's a subset of itself, right? 1, 2, 3, because it's with this line underneath it means equality is okay. But I cannot say something like this. I cannot say it's a proper subset. That's not correct anymore because they're equal, right? And this symbol right here does not allow for equality to happen. Okay, so that's the difference. Proper subset means basically you got to be a smaller set. So maybe that's another way of looking at it. Maybe an easier definition here. It's a subset that's smaller. That's the key. All right, guys. I'm pause this video. I'm gonna cut this video off. And then in the last video we will talk about the last.